Ever pondered over the enigma that is high-dimensional data in data science? It's like trying to navigate a maze with more than just the usual 3 dimensions. High-dimensional data presents us with a unique set of challenges. One of them is visualization. The human mind is adept at comprehending 3-dimensional data, but throw in a 4th dimension or more, and things start to get a bit tricky. Another challenge is the risk of overfitting in our models. As the number of dimensions increases, so does the complexity of our models. This can lead to a model that's too tailored to the training data and performs poorly on new unseen data. And let's not forget about the increased computational cost. More dimensions mean more computing power and more time needed to process the data. So how do we make sense of this high-dimensional data? The secret lies in dimensionality reduction. Dimensionality reduction, a fancy term, isn't it? But what does it truly mean? Let's delve into it together. Picture yourself in a crowded room full of chatter. It's overwhelming, isn't it? Everyone's talking, but do you need to hear every single conversation? Probably not. You'd want to focus on the most important discussions, the ones that make sense to you. Now imagine each conversation in that room is a dimension in a dataset. The room, buzzing with chatter, is akin to high-dimensional data in the world of data science. It's complex, it's overwhelming, and it's tough to make sense of it all. So what do? You simplify it. You tune out the noise and focus on the essential chatter, the conversations that matter. Dimensionality reduction is a process that takes this high-dimensional data, this crowded, noisy room, and simplifies it. It's like having a superpower that lets you instantly identify the key people in the room, the ones leading the important conversations. It allows us to reduce the dimensions of our dataset, hence the term dimensionality reduction, without losing the essential information. Think of it as a cocktail party trick. You're trying to find the most important people in the room, but you don't want to spend all night doing it. So you use dimensionality reduction. It helps you identify the important conversations quickly and efficiently, allowing you to make sense of the room without getting overwhelmed. But here's the kicker. While dimensionality reduction simplifies the data, it doesn't lose the important information. It's not about erasing the noise for the sake of peace and quiet. It's about identifying the essential, the meaningful, the significant. So next time you come across a high-dimensional dataset, remember the crowded room. Remember that you don't have to listen to every conversation. You just need to find the important ones. Hence, the magic of dimensionality reduction is its ability to simplify the complex without losing the essence. Now that we've unraveled the mystery of dimensionality reduction, let's solidify our understanding with some key points. Dimensionality reduction, in essence, is a process that simplifies high-dimensional data, making it more manageable and comprehensible. Imagine you're in a room filled with countless strings of yarn, each representing a different dimension. Dimensionality reduction is like a master weaver, turning that tangled mess into a beautiful, understandable tapestry. One of the prime reasons why dimensionality reduction is so essential is its role in tackling the curse of dimensionality. As the dimensionality of data increases, the volume of the space grows so fast that the available data becomes sparse, making it challenging to draw any meaningful conclusions. Dimensionality reduction steps in here, reducing the number of variables or dimensions, and making the data more concentrated, easier to handle and interpret. Another crucial aspect is the prevention of overfitting. Overfitting is when a model learns the detail and noise in the training data to the extent that it negatively impacts the performance of the model on new data. It's like memorizing the answers to a test instead of understanding the concepts. By reducing the number of features, dimensionality reduction helps prevent this, ensuring our model is better at generalizing and not just memorizing. Reducing computational cost is another feather in the cap of dimensionality reduction. As the number of features or dimensions decreases, so does the computational resource requirement. This makes the processing faster and more efficient, saving both time and computational power. Lastly, dimensionality reduction brings to life the possibility of meaningful data visualization. Visualizing high-dimensional data in its raw form is impossible. However, by reducing dimensions, we can plot and visualize data in 2 or 3 dimensions, making it possible to perceive patterns and relationships that would have been invisible in higher dimensions. Remember, dimensionality reduction is your secret weapon in making sense of the high-dimensional data chaos. Use it wisely and you'll unlock the true potential of your data.